Hi friends, welcome to the Unit 3 Day 7 notes. Now we're going to jump into polynomial inequalities. With polynomial inequalities, you start with a polynomial in standard form, then you want to factor it completely. And then when you factor it completely, you're going to plot your zeros on the x-axis, and note that we're going to just focus on the real zeros, and then also noting their multiplicity. Remember, if multiplicity is odd, the function changes signs. If the multiplicity is even, there's no change in sign. This part is key as we move on. Notice that this is 2a and 2b underneath 2. Use the end behavior to determine the sign in the outermost intervals. Then we need to label the other intervals as either positive or negative. By analyzing the multiplicity of the neighboring zeros, and then we're going to state the solution in interval notation. Set notation is just too cumbersome for this particular part, so we're just going to focus on interval notation for these things. First step is to get it in standard form. So what I'm going to do is I'm going to move everything over to the left-hand side. So plus 4x squared, and then minus 3x. So I have everything on the left-hand side. X cubed plus 4x squared minus 3x minus 18 is less than 0. So now looking at this, looks like I could do maybe a factor by grouping, so I'm going to check that. So I factor out an x squared, I'm left with x plus 4. Factor out a negative 3, I'm left with x plus 6. That's not a factor by grouping, so that won't work. So the next thing that I would do is I would just check synthetic division, finding the zeros, see which one's the best, starting with negative 1 and 1. For time's sake, I'm going to do that off camera, and then jump back with the zeros. So I will see you shortly. So jumping back in, I did synthetic division with 1, negative 1, and then 2. When I got to 2, I actually found that 2 was a factor, so that 2 was the solution, so x minus 2 is a factor. Then I'm left with this quadratic, x squared plus 6x plus 9. So now moving forward, I know that x minus 2, and then for here, I'm going to have x plus 3. This is a sum of squares, this x plus 3 squared, and then is less than 0. So now that I have my solutions, what I'm going to do is I'm going to visualize this on a graph. So making my graph off to the side here. So here I have a negative 3 as a solution, and then I have 2 as a solution. Okay, so now I know that this is a cubic. Leading coefficient is positive. So if it's cubic, that's an odd degree. And then my leading coefficient is positive. So then I know my end behavior for this particular type of graph is going to be down and then up. I know here, this x plus 3, this is where it's going to bounce. The graph bounces here, and the graph will cross or intersect here. So looking at my graph, I know that I'm going to be going something like this. It bounces, and then it'll go through here, and then continue on. So I want to know when the graph is less than 0. So that's going to be all of the values that are here. That's when my graph is going to be less than 0. So now writing my solution in interval notation, and this is going to give me from negative infinity to negative 3, non-inclusive, union negative 3 to 2, non-inclusive. So if this was less than or equal to 0, what would change? Instead of being non-inclusive here for negative 3 and 2, I would be including them because I would want 0. This is important to kind of sketch that. One thing to note is that another way to kind of look at this is to know that if this is going down, then this is going to be negative here. Your y value is going to be negative. Because it bounces, the sign doesn't change. That's what we're talking about here. The sign doesn't change because the multiplicity is even. So this is negative. And then it doesn't change here until we get to 2, so this part is positive. So if you think about these intervals, from negative infinity to negative 3, it's negative, negative, and then it's positive from there on out. It's another way to look at it. Here for the next one, solve the inequality. Again, we're going to get in standard form first. minus 9x squared on both sides, then plus 12 on both sides. So I have x to the fourth minus 9x squared plus 4x plus 12 is less than or equal to 0. All right, so just looking at this, looks like factor by grouping might work, but I noticed that this x, like if I take out an x squared from both of these, I need this to be cubic for it to actually function that way. So it looks like I might be back to doing difference of squares. No, not difference of squares. Maybe synthetic division. I think I'm going to end up with a difference of squares, though, at some point, just by looking at these two here. Yeah, that could be a possibility. Okay, so again, going to do some cuts as I run synthetic division, see how this works. I'll be right back. Hi friends, I had good luck with my first zero that I picked, -1, but then I didn't have quite so good luck as I was checking, and then I found 2. So then when I was finished, I got factored out the x plus 1 from this one working, and then the x minus 2 from this one working, ended up with x squared plus x minus 6. Factoring that out, I got another x minus 2 and then an x plus 3. So now, again, this is going to be a bounce, this is going to be intersect, that's going to be an intersect. So again, thinking about it graphically, I've got solutions at -3, at -1, and then at +2. And then this is an even degree with a positive leading coefficient. So I know it's going to open up and up here. So this is going to be, so I'm going to start out with a positive, values. We intersect here, so that's going to change the sign. That's going to change the sign, and then it bounces here, so that's going to be changing the sign. So it's going to do something like this. Something like that. So I want to know when it's less than or equal to 0. So it's only in between this area where we say that it's negative that it's actually going to be less than or equal to 0. So my interval for this one is going to be from -3 inclusive to -1 inclusive. So there's my solution for that. Join me in the next video as we now go into rational inequalities. See you then.